The beginning of 5.1 focuses on composition of functions. When you compose two functions, you're taking one function and putting it into another. It's important to note the different ways to show composition. This open circle is a symbol for composition. If it's filled in, that means multiplication. This can also be written as f of g of x. In other words, if I'm composing f of g of x, I am putting g of x into the f function in place of x. So let's look at this first example. We have f of x equals x squared and g of x equals negative 2x. And we're going to find these four things. So, for the first one, it says find f of negative 1. So if I'm finding f of negative 1, I'm using f of x. And in place of x, I'm going to put a negative 1. When I do that, I get negative 1 squared, which is equal to positive 1. For question B, I'm finding g of 7. So I'm going to use my g of x function. And when I'm finding g of 7, every place where I see an x, I'm going to put in a 7, substitute in a 7. So g of 7 is equal to negative 2 times 7, which is negative 14. For question C, I'm back to the f function. And in place of x, I am putting in a 3x. Notice that I am putting parentheses around the 3x, and that's really important in this example because I'm squaring the 3 and the x. To show that, I'm going to surround it with parentheses. And 3x squared would equal 9x squared. But this last one is a composition. And what this one says is I'm going to take my f function, and every place that I have an x, I am going to put the g function instead. So the f function says take x and square it. So I take my input and I square it. But the input in this example is g of x, which is negative 2x. So if I square negative 2x, I am taking negative 2 times negative 2, which is positive 4, and then that would be x squared. So let's look at example 2. In example 2, we're using two different functions. F of x equals x squared plus 1. G of x equals x minus 3. So I'm going to start by finding f of g of x. So what this means is I'm taking my g of x function and putting it in place of x in the f function. Well, my f function says x squared plus 1, and I always like to start by making a skeleton of my function and replacing x with parentheses. And that's why I put parentheses squared plus 1. Now what goes inside of the parentheses is g of x. So that would be x minus 3. Now be careful in this example because when we square something, we're multiplying it against itself. So you need to multiply x minus 3 times x minus 3. When you do that, you get x squared minus 6x plus 9. Bring down that plus 1 that was at the end, and then combine your like terms. So your final answer is x squared minus 6x plus 10. So now let's do g of x. And what that means is I'm taking my g function, which says x minus 3, and I'm putting the g function back into itself. So if my g function says take something minus 3, the something that I'm going to put in is the x minus 3. And when I do that, I'm left with x minus 6. Now in this function, it's asking us to input a number after we find our function. So we're going to substitute in a 3 right here. So that would be 3 minus 6, or negative 3. Now there is another way that we could go about doing it that we'll try in this next example. So in this next example, it says find f of x of 2. We can always begin by finding f of 2. So if I put find f of 2 first, then I would have 2 squared plus 1, which is 5. And then I'm going to take that answer and put it back into itself. So if I do that, I would have 5 squared plus 1, which is 26. If you don't want to do it that way, you can always do your composition to find your function and then substitute in the number at the end. If we do it that way, I would have to take my x squared plus 1. So I have x squared plus 1, but then I'm going to drop that same function back in it. And when I multiply x squared plus 1 times x squared plus 1 and bring down that 1 at the end, I have x to the 4th plus 2x squared plus 1. Bring down that plus 1, and that leaves you with x to the 4th plus 2x squared plus 2. When you substitute in a 2 for x, we will have 2 to the 4th plus 2 times 2 squared plus 2. 2 to the 4th is 16, plus 2 squared is 4, and 4 times 2 is 8, plus 2. And when you add 16 plus 8 plus 2, we still get 26. So that's 2 different ways to go about doing it, and you still get the exact same answer. So for this last one, in example D, I am going to find g of 4x, and then when I find that answer, I'm going to put that back into the g function. This is what this is asking us to do. So if I substitute in 4x here, let's start with finding g of 4x. Then I would have 4x minus 3. But if I take this function and I put that back into g again, then I have 4x minus 3 minus 3, which is going to simplify to 4x minus 6. And that is my final answer. All right, so let's just do one more example where we're using a quadratic and a square root. So in this first one, this means take my g function and put it into my f function. So my f function says something is squared, and then I'm adding 5. That's what the f function is telling us to do. But now the something that we're going to drop in is g, which is the square root of x minus 4. So in this section of our function, we are squaring a square root, and because they're inverses, they cancel. So we're left with x minus 4 plus 5, which results in x plus 1. Now let's go the other direction. If I take my g function and I rewrite that function. That function says take the square root of something minus 4. The something is x squared plus 5. Now in this example, we cannot cancel out the quadratic because we're taking the square root of more than just x squared. So we can't cancel it out. However, we can simplify it. So we end up with x squared plus 1 underneath my square root. This is not factorable, so that would be my final answer.